Okay, we're going to cover section 2.8. This section's about comparing fractions. So you would have two fractions, one on the right, one on the left. And in the middle, we would be looking for that greater than, less than, or equal to symbol to go in the middle of them. So we're going to work a little bit more with that. And then we are going to work on order of operations using fractions. Okay, so let's look at a couple of fractions. We're going to start with the comparing fractions. And so our first example is going to be 2/3 compared to 3/6. And remember how I told you before, it's very difficult to compare fractions when the denominators are not the same. So you would either need to change both fractions to have a common denominator and then look at the numerators to see which one is bigger, or you can use that cross-multiplying method that I have shown you in another section, and I'll review that right here. So we will start from the bottom and go to the top, and so I see in this section I have 3 times 3, which is in this diagonal, and I end up with 9. Since I end up on that right side of the top, I'm going to write my answer on that right side. And I start at the bottom with 6. 6 times 2 gives me 12, and I write 12 on the other side. And so now all I'm comparing is 12 on this side and 9 on this side. Which one is bigger, 12 or 9? And so obviously the 12 is. And so we're going to put a symbol in here that faces this direction because remember we pretend like there are little teeth on this, and the mouth is eating this bigger number here. Okay, so this symbol that we just wrote in there is a greater than symbol. Okay, remember the other one is a less than. You could tilt it a little bit and it looks like an L for less. So that's not the one we used. We used the other one, and so that's going to be greater. So if I plug that symbol in, we would say that 2/3 is greater than 3/6. And so this would be the answer that I would submit for this on a test or in my open math. Okay, let's try another one. The next one is 4/6 compared to 3/8. Okay, we do not have common denominators, so we're going to have to use this cross-multiplying to be able to find out which one's bigger. Or, instead of doing that, you could find a common denominator and change both fractions to have a common denominator and look at your numerators and see which one's bigger. That takes a little bit longer sometimes, so we are going to do the cross-multiplying. So 6 times 3 gives me 18. Multiply on the other diagonal, and I get 8 times 4, which gives me 32. And so I look at this and I say 32 is bigger than 18, so the mouth that goes in there needs to eat the 32, and so my final answer is this symbol right here, and that symbol is greater than. Okay, let's do one more and then we'll move on to some fraction work with order of operations. All right, the last one we're going to do of this comparing fractions is 1/2 and 3/4. They do not have a common denominator. But I can make them easily have one. So if you don't want to do the cross multiplying, you could do another method, which would be like this. You could have a new denominator of 4. What did I do to 2 to get to 4? I multiplied by 2, right? Do the same thing on the top, and so I end up with 2/4 compared to 3/4. Sorry, don't ignore that. And so now the 4's match on the bottom, so I'm just comparing 2 and 3, and which one is bigger? The 3, and so we would put this symbol in here. So if you're not sure if that really did work, you could double check it and you could do the multiplying from the bottom to the top and get 6, from the bottom to the top and you get 4, and you're comparing 4 and 6, and which one's bigger? 6. And so we found that the less than symbol is our answer for this one, no matter how we solved it. Okay, let's move on and look at some order of operation work. And remember, order of operations tells us we're using the please excuse my dear Aunt Sally rules. And this time we're not just solving with normal numbers or whole numbers, we're using fractions instead, just to make sure we know what we're doing that much better. All right, so this problem starts out very simple. That's it. It's 1/4 squared. And so remember what I told you is that the item or number that's inside the parentheses or that has the exponent attached to it is called our base. So the red 1/4 right there is your base, and the 2 is the exponent. And remember that all of our exponents here tell us how many times we see the base. Ooh, that's an M, sorry. Times we see the base. And so since we see the base 2 times, that means I'm going to take my base, which is 1/4, and I should have it twice. All right, so now I've got another set of rules, right? Now I'm multiplying with fractions, and so With multiplying of fractions, it does not matter if I have a common denominator. It doesn't matter because the rule for multiplying fractions is simplifying the diagonals where you can, and then and then multiply straight across the top and straight across the bottom. And so I cannot simplify in any of the diagonals, so I will multiply straight across the top and get 1, straight across the bottom and get 16, and so 1/16 is the final answer for this. Okay, let's move on and try another one. I've got 2/3, and it's also in parentheses, and it is also squared. So we're trying to practice these skills of parentheses and of exponents, and realize that the parentheses are not really telling us to do anything, especially if your problem is asking you to submit a final answer in a fraction form. We do know that inside those parentheses, that's actually a division problem. That's 2 divided by 3. And if I actually did that, it would give me a decimal, and then I would have to turn around and put it back into a fraction form for my final answer. So it's much easier to deal with this in fraction form as long as you know what the rules are. So this tells me that the base is what I have inside, so that's where I get the 2/3. And how many times I have it is told to me by the exponent. So I'm going to take my base 2/3 and I'm going to write it twice. There is no simplifying to be done in either of the diagonals, so I multiply straight across the top and get 4, straight across the bottom and get 9. Be very careful because some of you want to say 4 and then you want to say 6 for the denominator. We're not adding, remember, we are multiplying. So 4/9 is my final answer. All right, so we're going to move into some that are a little bit more complex. We're just working our way up a little bit. This is an addition problem. I'm going to put these in parentheses, and then I'm going to multiply by 1/2. All right, so according to the order of operations, we have parentheses, and the parentheses that we see are right here. And so they tell us to take care of everything inside these parentheses first, and then we'll move on to something else in this order of operations, because parentheses obviously comes first, because that's what the P is for. So I'm going to add this 1/3 plus this 5/6. Okay, I need to do that only when I have a common denominator, and I do not. So I know that little shortcut that I have taught you, and I multiply my denominators together, and I get 6 times 3 is 18. And so I found an 18 as a new common denominator for both of these fractions. I'm then going to multiply from the bottom to the top, and 3 times 5 is 15. I ended on the right side, so the 15 goes on the right side. I multiply from the bottom to the top, and 6 times 1 is 6. I finished on the left side up here, and so my answer stays on the left side. So here's this fraction, or these 2 new fractions that I have, and I could really write this out so you could see really what I'm dealing with right here. I can't forget the rest of this problem. Just because I'm not using it right now doesn't mean that it goes away. So all I'm doing is putting these 2 together, and remember I draw that little V shape to tell you that these 2 are funneling together to become an answer. So 6 plus 15 is, let's see, well 15 and 5 would be 20, plus 1 more would be 21 over 18. Ooh, that's messy. Over 18, and then I've got times 1/2. The 20 is going to be really good to be simplified first as we move on. It's going to be just easier to use, okay? Because we're going to multiply it by the half in just a minute. Just simpler numbers are always nice. So what I'm going to do is I'm actually going to simplify this 20 over 18, and I'm going to divide both of them by 2. And so I'm simplifying this fraction, and I end up with 10 over 9. I'm going to multiply it by 1/2, okay, because that's this piece right here that I haven't used yet, right? This whole piece that I keep bringing down each time. And so all of this became 20 over 18. I divided the 20 and the 18 both by 2 to simplify it, and that's where I got this 10 over 9. Okay? It's okay that 9's on the bottom and it's smaller because 18 was smaller than 20, and that's still okay. I do not want to change this to a mixed number yet because I have to multiply it by a fraction, and when I multiply I have to have another fraction to multiply it by. I do instantly see though that I can divide and simplify here. Remember in the diagonal when you simplify you've got to divide by the same number, so 2 goes into 2 1 time and 2 goes into 10 5 times. So now I'm going to multiply straight across the top, and 5 times 1 is 5, straight across the bottom 9 times 1 is 9, and so 5/9 is my final answer for this problem. Oh, I wrote 20 and it should have been 21. I was like, why is this not correct? Okay, let me start over right here. When I added, let me show you where I made a mistake. When I added this and this together, I said it was 20 instead of 21. So I'm going to erase right here all the way down, and we're going to start this little part again. And see, that right there is how easy it is to make a mistake. So this should have been 21 over 18. Well, 21 over 18 is not going to simplify quite as easily. And so I'm going to go ahead and leave it just like that. And so I'm going to multiply where I can and simplify where I can. And so when I multiply, I end up with 21 over 36. Both of these would be my final answer, the 21 over 36. If it can be simplified, I will. And I know that I can simplify by dividing by 3. And so this is going to give me a final answer of 7/12. There. So make sure, just like I just did, prime example of why it's important to just look right back over your work and check and make sure that this all makes sense and looks right. Because just like I was talking out loud, I said 5 plus 15 gave me 20, but it was actually 6 right here. And so I said plus 1 would give me 21, and I still wrote 20. So just be careful. Do that, what I just showed you, and check your work and catch your mistakes before you turn them in. All right, let's try another one. Let's do 2/5 divided by 3/10. And then let's multiply it by 1/2. Did I just do this problem? No. All right. This one does not have any parentheses in it, but our order of operations tells us which one goes first. And I'm going to write it out to show you. So no parentheses, no exponents, multiply and divide. Remember that they are equals. So if you can remember back to how I told you this, we're just going to work this problem moving from the left towards the right. So whatever I come to first, which are these two, I will take care of. I'll bring that answer down right here, and then I'll bring down the rest of this, and I'll multiply second. So I've got to first make myself some space here and go ahead and do this division part. So the rule for dividing is it doesn't matter what the denominators are, but I have to keep it, change it, flip it. So keep it the same, change it to multiply, and flip it over. And so from here, I'm just ready to multiply like I have been. I'm going to simplify in every diagonal that I can. I'm going to divide by 5, and I get 1 here, divide by 5, and I get 2. I'm going to multiply across the top and get 4, across the bottom and get 3. So this whole piece became 4/3. Okay, what have I not used? Well, I've not used this multiplying by 1/2 right here, and I'm going to bring it down. So times 1/2. This is not a keep it, change it, flip it, because it's multiplication already, so you do not have to do that. But I am going to simplify by dividing by 2 in both of these diagonals. And I have 1 and 2 here. As I multiply across the top, 2 times 1 is 2, and 3 times 1 is 3. So this final answer for this problem is 2/3. Okay, we're going to do one more that has a little more complex of steps, I guess, is a better way to say that. We're going to use some exponents in this next example. So this is going to be 3/4 times, we've got parentheses around this, 1/2, and this 1/2 is all raised to the second power, or squared. All right, so according to the order of operations, it's please excuse my dear Aunt Sally. I have parentheses, but inside these parentheses, I'm not doing anything. It's just a fraction being held together there. But it does have an exponent, and that's why the parentheses are there. It's saying everything in the parentheses are raised to the second power. So if I solve the parentheses exponents portion right here, what I'm really doing is taking the exponent, the base that I have inside, which is this red 1/2, and I'm taking it twice because this exponent up here tells me I have 2 of them. So if I simplify this in the diagonals, which I cannot, I'm going to multiply straight across the top and straight across the bottom. And 1/2 squared turns out to be 1/4. So this funnels down and becomes 1/4, and I'm going to bring down everything that I haven't used, which is the 3/4 and the multiply sign. Okay? From here, I need to multiply 3/4 times 1/4. I'm going to simplify in the diagonals if I can. If I cannot, which I can't, I'm going to multiply straight across the top and straight across the bottom. If I could simplify 3 and 16 in any way, I would, but I cannot. So 3/16 is my final answer. All right, so that is all for section 2.8.